6200. What type weather can one expect from moist, unstable air and very warm surface temperature? A. Fog and low stratus clouds. B. Continuous heavy precipitation. C. Strong updrafts and cumulonimbus clouds. The correct answer is C. When moist, unstable air interacts with a very warm surface temperature, it creates an environment conducive to the formation of certain weather conditions. Specifically, two significant characteristics emerge: strong updrafts and the presence of cumulonimbus clouds. Moist, unstable air refers to an air mass that contains a significant amount of moisture and is characterized by vertical instability. In this context, vertical instability implies that the air is capable of rising rapidly due to factors like convective heating or lifting mechanisms in the atmosphere. When such moist, unstable air encounters a very warm surface temperature, it further enhances the instability. The warm surface temperature provides a continuous source of heat to the air above it, causing it to become buoyant and prone to upward motion. This combination of moist, unstable air and a very warm surface temperature results in the development of strong updrafts. Strong updrafts refer to the rapid vertical ascent of air masses. As the warm, moist air rises, it experiences reduced pressure, expands, and cools. The cooling leads to condensation and the formation of clouds. In particular, cumulonimbus clouds are associated with these weather conditions. Cumulonimbus clouds are tall, towering clouds that can reach significant altitudes in the atmosphere. They are characterized by their anvil-shaped tops and are often associated with severe weather phenomena such as thunderstorms, heavy rain, lightning, and sometimes even hail. In summary, when moist, unstable air interacts with a very warm surface temperature, the resulting weather conditions are marked by strong updrafts and the presence of cumulonimbus clouds. These conditions often indicate the potential for severe weather events and intense convective activity. 6201. What is a typical characteristic of a stable air mass? A. Cumuliform clouds. B. Showery precipitation. C. Continuous precipitation. The correct answer is C. A stable air mass is typically characterized by the presence of continuous precipitation. In a stable air mass, the vertical temperature distribution is such that cooler air is situated closer to the surface, with warmer air above it. This vertical temperature profile inhibits vertical air movement, preventing the air from easily rising or sinking. As a result, when an air mass is stable, the ascent of moist air is limited. The air remains relatively stagnant, and any moisture within the air tends to condense and form clouds over an extended period. This condensation process leads to continuous precipitation, which can manifest as steady rain, drizzle, or even a prolonged period of light to moderate rainfall. Unlike showery precipitation, which occurs in association with unstable air masses characterized by convective activity and rapidly rising air, continuous precipitation in stable air masses is more consistent and uniform. It is often associated with stratiform clouds, which are typically flat and layered clouds that extend over large areas. Therefore, the presence of continuous precipitation is a typical characteristic of a stable air mass, reflecting the steady nature of rainfall or drizzle that occurs when the air remains relatively motionless and lacks the vertical instability seen in more convectively active conditions. 6202. A moist, warm air mass that is being cooled from below is characterized, in part, by A. Smooth air. B. Cumuliform clouds. C. Showers and thunderstorms. The correct answer is A. When a moist, warm air mass is being cooled from below, one of the characteristics that can be observed is the presence of smooth air. As the warm air mass encounters a cooler surface below, such as a body of water or a cooler landmass, the cooling process begins. This cooling causes the air to become denser and more stable. When the air mass is stable, it inhibits the vertical movement of air and suppresses the development of turbulent air currents. The result is a relatively calm and smooth air mass. The absence of significant turbulence or strong vertical motion creates a more serene and stable atmospheric condition. In such circumstances, air movement tends to be more gradual and less erratic. Smooth air conditions can have implications for various activities, including aviation, as it generally provides a more comfortable and stable experience for aircraft and passengers. Additionally, smooth air is often associated with clear or lightly clouded skies, as the stable air suppresses the formation of convective clouds, such as cumulonimbus clouds, which are typically associated with more turbulent and active weather patterns. In summary, when a moist, warm air mass is cooled from below, it leads to the development of smooth air conditions. This implies reduced turbulence and a more stable atmospheric state, which often translates into calm and serene weather conditions with minimal vertical air movement. 6203. Frontal waves normally form on A. Stationary or occluded fronts. B. Slow-moving warm fronts or occluded fronts. C. Slow-moving cold fronts or stationary fronts. The correct answer is C. Frontal waves, also known as mid-latitude cyclones or wave cyclones, commonly form along slow-moving cold fronts or stationary fronts. A cold front is a boundary that separates a mass of cold air from a mass of warmer air. When a cold front is slow-moving or stationary, it provides a favorable environment for the development of a frontal wave. In this scenario, the contrast in temperature and moisture between the cold and warm air masses is significant. As the cold front interacts with the warmer air mass, it may begin to slow down or stall, creating a region of convergence where the contrasting air masses meet. This convergence can lead to the formation of a wave-like disturbance along the front. The formation of a frontal wave involves a cyclonic circulation pattern. As the cold front interacts with the warmer air, it lifts the warm air and creates a frontal boundary with a gentle slope. This boundary forms the basis for the development of the wave-like disturbance. Within the frontal wave, air flows counterclockwise in the northern hemisphere, clockwise in the southern hemisphere, around a low-pressure center. Frontal waves often play a significant role in weather systems, influencing the movement and intensity of precipitation, as well as the distribution of air masses. They are associated with a variety of weather conditions, including cloud formation, rain, and sometimes severe weather such as thunderstorms. The movement and evolution of frontal waves can have a profound impact on weather patterns over a large geographical area. In summary, frontal waves typically form along slow-moving cold fronts or stationary fronts. These wave-like disturbances develop due to the interaction between the cold and warm air masses, resulting in cyclonic circulation and significant weather changes. 6204. Cool air moving over a warm surface is generally characterized by A. Instability and showers. B. Stability, fog, and drizzle. C. Instability and continuous precipitation. The correct answer is A. When cool air moves over a warm surface, it creates an atmospheric condition characterized by instability and the potential for showers. As the cool air mass interacts with the warm surface below, such as a body of water or a heated landmass, it undergoes a process known as advection. Advection refers to the horizontal movement of air, in this case, cool air moving over a warmer surface. This temperature contrast between the cool air and warm surface creates instability within the lower atmosphere. Instability refers to a state where the environmental lapse rate, the rate at which temperature decreases with increasing altitude, exceeds the adiabatic lapse rate, the rate at which temperature decreases as air rises. The instability promotes vertical air motion as the cool air rises, being buoyant over the warmer surface. This vertical motion leads to the formation of convective clouds, which are characterized by their vertical development. Showers are a common outcome of this process. They occur when the rising, moist air cools and water vapor within the air condenses, forming visible cloud droplets. These convective clouds generate localized areas of intense rainfall, often in the form of showers. Showers typically have a sporadic nature, with periods of heavier rain followed by breaks or lulls in precipitation. The instability associated with cool air moving over a warm surface also creates favorable conditions for other convective phenomena, such as thunderstorms. Thunderstorms can develop when the instability is particularly strong, leading to the formation of cumulonimbus clouds, lightning, and potentially more significant precipitation. In summary, when cool air moves over a warm surface, the resulting atmospheric conditions are characterized by instability and the likelihood of showers. The temperature contrast and vertical motion in the atmosphere create an environment conducive to convective cloud development and sporadic episodes of rainfall.